Hi, Guy Manoj James here. In this video, we are going to look at the second technique of anti-differentiation, which is linear substitution. In the previous video, we looked at the first technique that you can use to differentiate complex numbers, to anti-differentiate complex numbers, and that technique is substitution, where the derivative is present in the integrand. And in the first video, we discussed that technique, and it applies especially to where you can recognize a derivative in the function. But there are cases where the derivative might not be present, that when you differentiate a function, it does not cancel out the function which is outside the bracket. So in this case, we use linear substitution for us to get rid of the function outside the bracket, or better still, solve it in a simple way. And I'm going to use these three examples as I used three examples in the previous video to show how to use linear substitution to solve special functions that you can solve using substitution where the derivative is present in the integrand. This one is the second technique, and there are two more techniques that I will cover in two videos. So you have to make sure that you follow these videos by subscribing to my YouTube channel and clicking the notification bell so that you can be notified whenever I post a new video. These four techniques will help you lay a solid foundation in integral calculus so that you can solve more complex numbers simply, like when you go to deal with differential equations and stuff like that. So let's get right in by solving the first problem. Now in this first problem, you can recognize that we have x as a function outside the brackets, and when you differentiate the function inside the bracket, it does not give us x. The derivative of x minus 1 is instead 1, which does not help us cancel out of x. And this is where this technique comes in handy, because here you are going to say let u be x minus 2, and then you're going to say x will be u plus 2 when you make x a subject, and then you find the derivative of this, which is 1. Du out of dx is 1, and therefore dx is simply du. So now what you need to do here is to put all this stuff into your initial function. If x is u plus 2, then it's going to be u plus 2 outside bracket, because we have put u plus 2 in the position of x. And then x minus 2 is now u, so you're going to put u here, raised to power 5 out of 2. And recognize that our dx is now du, so we're going to say du. Alright, so you have to open your brackets now. When you open your brackets, u times u raised to power 5 out of 2 will be u raised to power 7 out of 2. 2 times u raised to power 5 out of 2 will be simply 2u raised to power 5 out of 2 du. Now you can integrate these functions plus the integral of 2u raised to power 5 out of 2 du. So the integral of u raised to power 7 out of 2 is u raised to power 9 out of 2 outside all over 9 out of 2, plus the integral of 2u raised to power 5 out of 2 is 2 times u raised to power 7 out of 2 outside 7 out of 2. Alright, du. The next thing you can do here is to do the reciprocal of the denominators, so that it can be 2 out of 9 u raised to power 9 out of 2 plus 2 out of 7 times 2 will be 4 out of 7 u raised to power 7 out of 2. Alright, now you can substitute u, the value of u, which is x minus 2. So it's going to be 2 out of 9, and then you put x minus 2, 9 raised to power 9 out of 2 plus 4 out of 7, x minus 2 raised to the power 7 out of 2, and then plus c. Now this should be your final answer. You can go further to simplify it by isolating x minus 2 raised to the power 7 out of 2 outside the brackets, but that can be tedious and it can give you, sometimes it can draw problems to your solution, so you can leave it this way. And this is pretty much it. Now let's go to the second problem. We can use the same technique in the second problem. Recognize that when you say your u is x plus 2 and you differentiate it, it doesn't give you x squared, right? And if you take u as x squared and you differentiate it, it doesn't give you x plus 2. So you use linear substitution so that you can say u will be x plus 1, and then your du out of dx is going to be 1, so that dx is just going to be du, and then you can say x will be u minus 1. Alright, so you can substitute all this stuff to your initial equation. If x is u minus 1, then u minus 1 will be squared, because here is x squared. Alright, out of, and then u under root du, because now our dx is du. So now you need to simplify this. It will be u squared minus 2u plus 1 out of u du. Okay, so what you will need to do here is to say that u squared minus 2u plus 1 will be times u raised to the power negative 1 out of 2. So now you can further simplify this, and it will give you u raised to the power 3 out of 2 minus 2u raised to the power 1 out of 2 plus u raised to the power negative 1 out of 2. Alright, now you can integrate this function. So integrating this function will give you u raised to the power 5 out of 2 minus 2u raised to the power 3 out of 2 plus u raised to the power 1 out of 2. So now the second thing you can do here is to simplify this function by using the reciprocal of the denominators, by saying 2 out of 5 u raised to the power 5 out of 2 minus 2 out of 3 will be 4 out of 3 u raised to the power 3 out of 2 plus u raised to the power plus 2u raised to the power 1 out of 2. Now you can put the value of u. The value of u here is x plus 1. So it's going to be 2 out of 5. Then you put the value of u, which is x plus 1 raised to the power 5 out of 2 minus 4 out of 3 x plus 1 raised to the power 3 out of 2 plus 2 outside x plus 1 raised to the power 1 out of 2 plus c. Now this one is the solution to your problem, and this is the second problem. Now let's go to the third. The third problem looks intimidating to the beginners, but it is actually the simplest among these three problems. So let's solve it. Let me rewrite the problem here so we can see it clearly. So it is e to the power of 2x out of e to the power of x plus 1 dx, and then you need to integrate this. So what we can do here, we can say our u is going to be e to the power of x plus 1. Our du out of dx is going to be e to the power of x, where our dx is going to be du out of e to the power of x. Our e to the power of x is going to be u minus 1. So we can substitute this in our function. So it's going to be e to the power of 2x outside u, because our u is e to the power of x du, out of e to the power of x, because that is our dx here. So recognize that e to the power of 2x is the same as e to the power of x times e to the power of x. Outside, u times du out of e to the power of x. So e to the power of x will go with 1 e to the power of x here. And then we are going to remain with the e to the power of x out of u du. Note that our e to the power of x is u minus 1. So it's going to be integral of u minus 1 out of u du. So u will go with this u, and we are going to remain with 1 minus 1 out of u, because at this point we can integrate. So the integral of this is going to be u minus ln u, because the integral of 1 is x, but the symbol we are using is u here. It's going to be ln u, and then our value of u, as you can see, is e to the power of x. So it's going to be e to the power of x plus 1 minus ln e to the power of x plus 1 plus c. And this is the solution to our problem. Thank you for watching. Be sure to subscribe so you can follow up with me as I solve problems regarding integration, especially involving the 4 techniques. We are here to solve functions using the remaining 2 techniques, and I'm going to post a video soon. Thank you.